Hello everyone, welcome back to Code with Cougar. In the previous videos, we got an idea about array data structure. So in this video, we're going to talk about all the operations we can perform on an array structure. So the first operation that we are going to discuss about is an accessing an element from an array structure. Basically, we mean by reviewing the value of the element at a specific index. Then we are going to talk about insertion operation, adding a new element to an array at a given index location. Then we will be talking about deletion operation on array structure, basically removing an element from the array at a specific index location. Then we'll be talking about updating or modifying or bringing changes to the values of the element at a given index position. And then we'll be talking about searching operation on array structure, the sorting operation we can perform on array structures. Basically, by sorting, we mean arranging or rearranging the element of an array in a specific order, example, ascending order or descending order. Then we'll be talking about merging or combining two or more arrays into a single array, also called as a concatenation of array, appending or joining two arrays together. So they'll be talking about how we can split and divide an array into multiple smaller sub arrays. We'll be talking about traversing and visiting and processing each element of the array sequentially. So we'll be talking how we can get the size of an array. We will check if an array is empty or not. We can clear all the elements of an array. We can copy and create a copy of the array with the same or different elements. Then we'll be talking about reversing a given array. We will also be talking about substitution or replacing all occurrence of a specific value at the array with another values. We'll be checking the unique elements in a given array. We'll check for the equality of the two array, whether the given two arrays are equal or not. Then we will do slice extraction. Basically, we can extract a specific range of elements from a bigger array. So let's get started and talk about the different operations we can perform on an array. For this presentation, I'm again going to use a C# language. Some of the syntaxes may be different if you guys are using the other programming languages. So I have an array here. My array has elements 1, 2, 3, 4, 5, 6. So before we start, let me define a function. So every time I wanted to print my array, I can simply call this function and print the elements of the array. So I'm going to define a public static void function. This function doesn't return anything. So I'm going to call my function print. This function is going to take an integer array. I'm going to call it ARR. Then inside the function, I'm going to loop through the elements of the array using a for each loop. For each var item in ARR, I just want to print the uh, item. So let me print the items instead of each item in a new line. I'm going to print all item in a single line. I just want to provide a space between each item, or I can provide a comma. So let me provide a space in this case. So let's test our function and print this array, print ARR. So cool, the function works and I get all the elements of the array 1 to 6 is printed. So now let's talk about traversing over the elements of the array, basically accessing an element or retrieving an element of the array. So the first operation was to access the element of an array. So let me go here. So copy this. I'm gonna paste it here just as a note. To access the element of an array in C#, or most of the programming languages, we can just use the square bracket, and inside the square bracket, we are going to provide the index value at which we want to access that element. Suppose I want to access the element at index 3, so I'm gonna give my array name, then I'll provide an a square bracket, and inside this square bracket I want to provide the index value at which I want to access the element. So I want to access element at index 3. Remember that index values in an array starts from 0. So 1 has index 0, 2 has index 1, element 3 has index 2, and element 4 has index 3. So this line of code should print 4. So this way I can easily access the element of an array. So the second operation is insertion operation. Basically, we want to add a new element to a given index location. Next operation, we are going to insert or add a new element to the array at a given index or at the end of array. First, we are going to insert an element at the given index location. So say this is my array. What I can do, suppose I want to insert an item at index 2 here. So this is index location or index position. I want to insert a number, say I want to insert 25 here. So what I can do is, since arrays are fixed size, I cannot extend another box here and insert number 25. Since arrays have fixed size, once we define the size of array, we cannot either shrink that or we cannot extend that. So what I can do is I can create a larger array and I can copy all the elements of this older array to a new array. So I can create a new array which has at least one element bigger than the older array. So this older array has size 6. So I'm going to create a new element that has 7, size 7, 0, 1, 2, 3, 4, 5, 6. Okay. So I created a new array of size 7, starting from 0 going all the way to 7 minus 1, which is 6. So what I can do, I can start a for loop traversing from the beginning of the old array going all the way to the index location at which we want to insert the new item. So as I traverse, I just copy the elements of the old array to the elements of the new array. So I'm going to copy 1 here, 2 here. But once I reach index 2, so I don't want to copy, I get out of the loop and just I copy and insert number 25 here. Then using a second for loop, I will start looping from this index location going all the way to the end of the old array. As I traverse, I insert the index at location 2 of the old array at index location 3 of the new array. Suppose I created a new array. So what I can do is I say new array of I plus 1. This is 1. New array of I plus 1 equal to array or old array of I. So I want to copy item at index I of the old array to index I plus 1 of the new array. That's why I want to copy item at index 2 of the old array to item at index 3 of the new array. So 3 is going to be here. 4, which is at index 3, is going to be copied at index 4 of the new array. 5 is going to be copied here, and 6 is going to be copied here. So this way I can insert a new item at the middle or at the beginning of the given array. So let's write code for that. First, I'm going to either we can take the new item we want to insert from user and also the index location from the user. But in this video, I'm going to hard code everything. So the new element I want to insert, I'm going to define an integer variable and store the new element. Say I want to insert 25. Then I want to define another variable to indicate the index location at which I want to insert the location. In this case, suppose I want to insert an index 2. So I define 2 variables. We can, if we wanted to take these values from the user, when we want to take the index location from the user, remember to always check index cannot be -1 or index cannot be greater than array.length. Always check that. So if the user enters an index that is less than 0, that's going to be an invalid index location. Or if he enters an index that is out of array range, so we can also only accept index from 0 up to 5. But if a user enters index 7 or 8 or 9, so we don't have any location for that. So in that case we give an error. But for the simplicity, I have hard coded the index location and also the new element. So using a for loop, I can copy the elements from the beginning of the new array up to the index location. But before that, I'm going to create a new array which is at least larger than the given old array. So I can create a new array, say new array equal to new int of, I'm going to use the size of this old array using the length variable, array dot length property of the array plus 1. So we are creating a larger array which is at least one item larger than the old array. So using the first for loop, I'm going to copy the elements before the insertion point, copy the elements before index or insertion point. So for int I equal to 0, I less than index, I less than index, I plus plus. So as I traverse, I just simply copy new array of I equal to array of I. I just copy the elements. Once I reach the index location, so I want to insert the new item, so I can do that new array of index equal to new element. So after I inserted the new element here, I inserted 25 here, then I want to start looping from the index location and going all the way to the end of the array. Then let me write another for loop, copying elements after the insertion point. So for that, I use another for loop for int I equal to index location. I less than array old array dot length. Then I plus plus. So each time I traverse, I wanted to insert each element to one index greater. So array of I plus 1. I'm giving I plus 1 because we already inserted one item here, equal to array of I. So if I wanted to print my new array, so I can use the print function to print the new array. We should be able to see the new item inserted at the given location. So we were able to insert 25 at index 2 easily. So let me insert 25 at index 4 this time. So this way we can insert an item at a given location. But what if we want to insert an item at the end of the array? For that, we are going to create a new array again, which is at least one item bigger compared to the old array. So the last item is going to be empty. I'm going to start traversing over the old array. As I traverse, I copy each element of the old array to the new array. Once all the items are finished, then at the end of the new array, I can insert the new item. So for that, suppose I want to insert the new element at the end of the array. Let me delete all these lines of codes. So I need a new element to insert at the end of this array. So first I'm going to create a new array, and new array equal to new int of a size of the old array.length plus 1. So I'm going to traverse over the elements of the old array. As I traverse, I keep copying the elements of the old array to the new array. For each, I can use for each for each loop here. So for each var x in array, so I just simply copy new, or I need a counter here. So let me define a counter here, int counter, since I didn't use for loop, so I can define a counter here, counter equal to 0, new array of new array of counter equal to x. Okay, we just copy that. Then I'm going to increment my counter variable each time. So once I reach the end of the array, I can insert the new item at the end of array. So new array of counter, since counter is already incremented by 1, so I'm not gonna increment it again. Counter equal to new element. So let me print the new array. This way we can see we are able to insert a new element at the end of array. Now let's talk about removing an element from an array at a specific index location. So say I want to remove an element from index 3. So what I can do is I can create a new array which is smaller than old array. So this array size is 6. So I'm going to create a new array of size 5. Is going to have 5 cells, 0, 1, 2, 3, 4. Then I'm going to traverse from the beginning of the old array to index location. So I'm going to traverse here. I can simply copy each item to the index location. So I'm going to copy index 0 to 0 of the new array. 1 is going to be copied here, 2 is going to come here, and 3 is going to come here. Once I reach at index 3, which is at element 4, I'm going to skip this index location, and using another for loop, I can start from this index location plus 1. So suppose this is index location at which I want to delete an element. So the next for loop is going to start from index plus 1. So I can start from 4 and going all the way to the end of location. As I go, I can copy the element at index 4 to the element at index 3 of the new array. Suppose this is my new array. Using the second for loop, I can copy the index at index I of the old array, index I to index I minus 1 of the new array. That's why I want to copy item at index 4 of the old array to item at index 3, which is I minus 1. Then I will be 5. So I want to copy item at index 5 to at index 5 of old array to index 4 of the new array, which is index I minus 1 of the new array. And then 6 is going to be copied here, 5 is going to be copied here. So for that, let me first create a new array, a smaller new array. So again, I'm going to hard code the index location. So I'm going to define an integer variable and index to remove equal to, suppose I want to remove index 3. So what I can do is I can create a new array and new array equal to new int of old array arr dot length minus 1. So I'm going to create a smaller array this time, since I want to delete an element from the old array. First, I'm going to copy elements before the index location to remove. So copy the elements before the index location to remove. So using this for loop, I'm going to copy all these elements up to the index location. So I can start from 0 and go all the way to the index to remove location for int I equal to 0, I less than index to remove, then I plus plus. I can just simply copy the elements of the old array to the new array of I equal to old array, which is arr of I. Then I'm going to copy the elements after the index to remove, or shifting the element to the left. So copying the elements after the index to remove. I'm going to escape the index location and the item at this index. So I'll be escaping this item That's why I want to start from index plus 1. So I can say for int I equal to index to remove plus 1, I less than array old array dot length I plus plus. So what I can do is I shift each element to the left by a new array uh, new array of I minus 1 equal to old array of I. So this way I can shift each element, and also I escape the item at index to remove. So if we print the new array, so the element at index 3 should be removed. Let me print that. So we can see we have 1, 2, 3, and 4 is gone. We have 5, 6. So let's remove item at index 1, which is item 2. As we can see, 2 is gone. We have 1, 3, 4, 5, 6. But what if I wanted to search for an item, and if that item is present at the array, I want to delete that item. This way we could easily remove an item from an index location. But what if we wanted to take the item from the user? First, we are going to search the array. If the item is present in the array, we want to delete that. Otherwise, we don't want to do anything. So suppose I want to item to delete. Suppose I want to delete number 3. So I'm going to assign index to remove to -1, since we assume that we haven't found the item to be removed from our array. So using the while loop or for loop, I can search through this array items and see if the item to be removed is present or no. So I can use simply a for loop for int I equal to 0, I less than array dot size or array dot length I plus plus. So I'm going to search if the item is present in the array. If array of I equal to item delete, then what I can do is let me define a flag variable here, or a boolean variable, bool found equal to false. So we assume that we haven't found the value, but once we found it, so if the item at index I is equal to the item to be deleted, we are going to set found equal to true. Then we break out of the loop, and we also want to set the index to be removed to the to I, okay, because we want to remove the item at index I. We found it at index I, and we want to remove that from the index I. So then here I have created a new array, okay, for I. Here I want to check before creating a new array, if we founded the element, so I just want to remove it and print the new array. I'm going to copy cat all these codes and paste it inside the if statement. Then inside the else block, if we didn't found it, we just want to give a message to the user, item and not found. And we don't want to do anything. Let's try that. So item 3 was deleted. Let's delete item 6. 6 is gone, but what if I want to delete 69? Item not found. Next, let's talk about update or modification operation. It's basically changing the value of an element at a specific index. This is going to be an easy task. Suppose I want to change item at index, say index equal to 2. I want to change the item at index 2 to a new item, so new item equal to 900. So I want to change item at index 2 to the 900. So I can easily do that by accessing the elements of the array and array of index. I just want to set it to new item. So this way we can change or modify the elements of the array at a given index position. If I wanted to print the array right now, so the element at index 2 should be 900. We can see that item at index 2 or allocation 2 is changed to 900. Next, let's talk about search operation. Basically, we want to find the index or presence of a specific element in array. To search for the index or presence of a specific element in a given array, in C# programming language, we can use the array.indexOf method, or we can loop to iterate through the array elements and check whether the desired item is present in the given array or not. So let's first use the array.indexOf method. Array.indexOf method. This method comes from this class. This class is part of the system.namespace, the system namespace. And basically, this indexOf is a static method. We can directly access it using the class name. So I'm going to call array dot indexOf. As we can see, this indexOf method takes an array and also it takes an object value. So I'm going to pass my array and also pass a value which we want to search. So I'm going to define, we can pass it directly, but I'm going to store it in a variable so that we can use it later on. Item to search equal to, say I want to search number 3, so I can pass item to search here. This indexOf variable, indexOf method, we can see returns an integer value. If it found the item in the array, it will return the index of that item. If it didn't find, it's going to return -1. So I'm going to take the index in index equal to whatever this indexOf method returns. So if the item was not found, it will return -1. So we are going to check if index equal to -1. If it is -1, so the item is not found, we can just simply print item not found. Else we are going to print item found. Else print item found at this index location. So let's run our program. We can see item found at index 2. Suppose I want to search for number 6. So item found at index 5. If I want to search for 66, item not found. So the second method is to loop through the items of the array and check whether the item is present or no. So next we are going to iterate through the elements of the array using a for loop. So I can do for int I equal to 0, I less than array.length, then I plus plus. So each time I loop through elements of the array, I'm going to check if array of I equal to item to search. If that is the case, so I'm going to define the index also here. Maybe we want to print the index, so int index equal to 0. Also, I'm going to take a flag variable of type boolean found equal to false. First, we are assuming that we didn't find the variable or the value. So if found, if array of I equal to item to search means that we found it. So we are going to set index equal to I. We found the item at index I. And also we are going to change found to true. So means we found the item. And also once we found it, so we are going to break out of the loop, and outside the loop we check if item was found, so we can simply print it, or if found is equal to true, we just print item found at index location. Else we just print item not found. Let's run our program. Item not found, 66 is not present in our array. Suppose I want to search for 6. Item found at index 5. Let's search for 1. Should item found at index 0. Let's search for 4. Item found at index 3. So now let's see the sorting operation. By sorting, we basically mean arranging the elements of an array in a specific order, for example, in ascending or descending order. For this video, I'm going to use the array.sort method, the built-in array.sort method. We are not going to talk about the sorting algorithms in this video. In the future videos, in the sorting algorithm section, we will be talking about different sorting algorithms. For example, we have bubble sort, we have selection sort, we have insertion sort, we have merge sort, we have quick sort, we have heap sort. We'll be talking about how differently we can sort the items of a collection, and we'll be talking about their time complexity. But for this video, we will be using array.sort method. Array.sort this method takes an array, so I'm going to use array 1 here. So before that, this is already sorted, so let me add some few items here. Let me add 20 here, let me add 33 here, let me add -1, and then 55, 0, 77. So this is an unsorted array. Before sorting, let's print that so that we can see the sorted and unsorted array of as. So after sorting, I'm gonna print it again, array 1. So this first line shows that unsorted array, but the second line we can see that our array is sorted in ascending order. But in order to sort it in descending order, what can we easily do is we can reverse the sorted array. After we sorted our array, we can just simply reverse it. So we can use array dot reverse order to reverse the sorted array, so it's going to sort our array in descending order. Let's print that. Now we can see that the largest element is going to be the first element, and the smallest element is the last element of the array. This was quick operation on how to sort the elements of an array in C#. So now let's talk about merging or combining two or more array into a single array. So this operation also called concatenation or appending or joining arrays together, two or more arrays together. So there are two basically methods. Again, we can use the built-in concat method, or we can manually do that by creating a new array. So I'm going to show you both ways. Before that, let me create a new array so that we can combine them. I have array 1, so I'm going to create a new array, array 2. So this array 2 is going to have elements like 100, 200, this element 44. So to do that, we can define an array and new array equal to, I'm going to use the concat method. So I'm going to say array1 dot concat, and then I will pass an array 2 here. So since this is not an this doesn't return an array type, so we gotta convert it to array using the toArray method. So it gives an error. And okay, this is not an array. We gotta give it an array here. So the error is gone. So let's print the new array here. We can see that the two arrays are combined together, but this was the built-in method. The other way we can do is, suppose I have two smaller arrays. uh, Say I have an array of size 3 0 1 2. Then I have another array of size, say this size is 4 and this size is 3. What can I do is I can create a new array of size 7. 3 plus 4 is 7. So I'm going to loop through the elements of the first array and copy each element of the first array to the new array. Then I'm going to loop through the elements of the second array and copy the elements of the second array to the new array. So this way we can combine multiple sub arrays into one single array. So let's go to IDE. Let's combine three arrays. Let me define another array, ARR3 equal to, let's say this one has 22, 33, 44. So to create a new array of the size same as size of the three of them, so I can do int new array equal to new int of so I'm going to use the size of array1 dot length plus array2 dot length plus array3 dot length. So now new array is big enough to accommodate the elements of all the three arrays or sub arrays. So to do that, first I'm going to define an index counter for the new array of type integer. Let's call it index or counter equal to 0. Then first I'm going to loop through the elements of the first array using a for loop or for each loop. So I'm going to use for each var item in array1. So simply I'm going to copy the elements of array1 to new array. So new array of index equal to item. So once I added the first item and index value is 0, so the first item will be inserted to the 0th location of a new array. After I read the second array, so I should increment the index value. So I say index plus plus. So I want to loop through the elements of the all three arrays and copy them to the new array. So for each item in array 2, then for each item in array 3. So if I print new array here, so it should have all the elements of the three sub arrays. So we can see that the new array contains the elements of all three sub arrays. And so 20 here, 20 is the first element, 33, and the last element should be 33, 44, 33, 44. So this way we can combine two or more sub arrays into one big array. Now let's talk about a splitting operation. It's basically dividing an array into multiple smaller arrays. So we can also extract a part of array, extract sub array from a given array. First, we are going to extract a sub array from a given array. Suppose this is our array here, and I want to extract a sub array from index 3. So I'm gonna take from index 3, and I want to extract 4 elements. So I'm going to have an index value, then a size of the sub array. Okay. So I want to start from index 3, and I want to say want to extract 2 elements. So I want to start from here. I want to extract 2 elements, so my sub array is going to have element 4 and 5. So if I wanted to put the size as 4 and start from index 2, So I can start from index 2 and go all the way to 4 elements. My sub array is going to be 1, 2, 3, 4. So my sub array is going to be of size 4, and the elements is going to be 3, 4, 5, and 6. So for that, let me define the index value first. We can take the index value from user, or we can define it here, hard coded. So let's define the index, or start an index. Suppose I want to start from index 3, and the size of the sub array is going to be, say I want to extract 4 elements. Before extracting elements, let's check whether the size doesn't exceed the size of the array. Suppose I want to start from index 7 here, and I want to extract 5 elements. We don't have 5 elements here. An array will go out of bounds. So in that case, it will give an error. Or what if the user inserts an index that is less than 0? So if index is -1, -2, so this is also not going to be an invalid index. Before doing anything, we are going to check for the index. So for that, I'm going to add index entered plus size. If this index plus size exceeds the size of the array, then that's going to be an invalid index value, so we cannot do anything. So before that, I'm going to check if index plus size is greater than array 1 dot length, so means we cannot do anything. Or if index is less than 0, so in this case it's going to be invalid index value, so we can just simply prompt the user invalid index values. Else we can extract a sub array from this given bigger array. For that, I'm going to define a new array. Let's call it segment, and new array or sub array. Let's call it a sub array equal to new. The size of the sub array is given here, so we want the size to be 4. Sub array of size. Then what we can do is we can start from for each element of the sub array for int I equal to 0, I less than sub array dot length or size, and then I plus plus. So for that, we are going to insert each element from index value. So since we want to start sub arraying from index 3, so we will insert elements from index 3 to the new array or sub array. So sub array of I, the first element of the sub array is going to be the element at index 3 of the old array. So array 1 of index value, then I'm going to increment the index here, index plus plus. So this way we can extract a sub array from a given array. So let's print the sub array here, print sub array. Let's run our program. Hope it doesn't give an error. No, it doesn't. So we are starting from index 3, 0, 1, 2, 3, going all the way to 4 elements. So 4, 5, 6, 8 should be printed. 4, 5, 6, 8 is printed. Cool. So say I want to insert 6 elements starting from index 2. So it should work. Cool. 3, 4, 5, 6 up to 9. Okay, well, if I want to give the size as 9, so it goes out of the bound, so it should not work. Invalid index value. Cool. Let's give it as 5, and let's this time give the index value as -1 or -2, so it shouldn't work too. Invalid index. So this way we can extract a sub array from a given array. Now let's talk about splitting an array into two parts from a given index. Suppose I have this array and I want to split this array from index 3. So I'm going to split this array from this index. So this is going to be one sub array and this is going to be the second sub array. For that, I'm going to create an array of size from 0 to the index value. Suppose I want to say index equal to 3, index equal to 3. So my first sub array is going to be of size 3. My second sub array is going to be of size equal to size of the second sub array is going to arr dot length of sub array length of the old array or the given array minus the index value from which we want to split the array. In this case, length of array is going to be 9. 9 minus 3 is going to be 6. So the length of the second sub array is going to be 6. 1, 0, 1, 2, 3, 4, 5. So these 6 elements is going to be copied in the second sub array. For that, let me first define a variable index from which index we want to split the array into two parts. So I'm going to call it int index or a split index equal to 0, say 3. So first I'm going to define two sub arrays int segment 1 equal to new int of the size of the index, which is 3. Then I'm going to define a second sub array or segment 2. Segment 2 equal to the size of this array is going to be the size of main array minus index. So I'm going to say array1 dot length minus index. So first I'm going to take a counter for the index values of the main array. First I'm going to assign the counter to zeros and counter equal to 0. So for int I equal to 0, I less than segment 1 dot length I plus plus. So I'm going to first fill the elements of the segment 1 sub array. So for that I'm going to do segment 1 of I equal to array 1 of counter plus plus. So I'm going to increment the counter value each time. Same we can do to fill out the elements of the second segment. In this case I'm going to do segment 2. So segment 2 of I equal to counter plus plus. So if I print segment 1 here, segment 1, then if I print segment 2, so before that let me print the main array also, print arr1. So if I run my program, we can see that our array is splitted into two parts, 1, 2, 3. Then the second segment is going to have 4, 5, 6, 7, 8, 4, 5, 6, 7, 8. Say I want to split my array from index 6. So the first sub array or first segment is going to have 6 elements, and the second sub array is going to have the rest of the elements. So this way we can split an array into two parts. Next, let's talk about traversing of an array. Basically, by traversing, we mean visiting each and every element of an array and processing each and every element. We have seen many times the traversing. For traversing, we can use either for loop or for each loop or a while loop. What we can do is we will take an counter, say I. We initialize the counter to 0. Basically, this counter I represents the each index value for each array element. So first I is 0, I is going to represent index 0. Then the second round of loop we are going to increment I by 1, so it's going to be 1 and representing the second item in array. Next I is going to be incremented and it will represent the index value of the third element. We go all the way to I less than length of array. Once I is less than length of array, once I gets greater or equal to length of array, then we will exit out of the loop. That way we can traverse through all the elements of the array. We have seen it many times using a for loop for int I equal to 0. This I is the loop counter. So this represents the each index value. I less than array1 dot length I plus plus. So each time we loop, I value increments and it checks whether I value is less than length. In this case, our length is 10 starting from 0. When I value is 8, we go inside the loop. But when I value becomes 9, 9 less than 9 is false. So we get out of the loop. So we can access each element inside the loop and process that. Suppose I want to access each element and add number 10 to each element of the array, then I will print it. So I can do array of I plus equal to 10. So I want to add a number or process each element. So let's call it process. Then we print it, print array of I. So this way we can say we added 10 to each element of the array. Next, we saw we can access each element of array using a for each loop. For each var is the data type. If we don't know the data type of our array elements, so we can use a variable data type, which is var. In this case we know that, so I'm going to define an integer type item in array1. So for each element I'm just going to print it, print arr of print item. So what is going to do, for the first round of the loop, item will be equal to 1. Then for the second round of the loop, item will be 2, 3, 4, 5, up to the end of the loop. If I print that, we can see that we print the array 2 times. The next method to traverse over the elements of the array is using a while loop. So I'm going to again define a counter. So let's call it I equal to 0. So we use a while loop while I is less than array dot length. So we traverse over the array. So I want to just print them. So array of I want to access it, then I will increment I each time. So until I is less than array.length, first time I will be 0, 0 item will be printed, then I will be incremented by 1. The next round of the loop, item 1 will be incremented and I value increment by 2. Like that, it goes all the way. Once I value becomes 9, 9 is not less than the 9, then it will break out of the loop. So this is the other way we can access the elements of an array. Next, let's talk about how can we get the length of an array. Suppose I want to get the length of this array. We can simply do a cout or console.writeLine array1 dot length is going to print the length of array or the size of array. But for most of the programming languages, if we don't have this length attribute of array, we can do it manually by creating int a counter. Let's define our counter to 0 for each. We can use for loop or for each loop var x in array1. We just want to increment the counter or the size. In this case, we define counter, or we can define a size here. We can increment a counter by 1. Then finally, we can just print the counter value. This way, we can calculate the size of the array. This is again linear time complexity. This is not a good practice to do. Since we have the length attribute, we can simply use that one. But in some programming languages, If we don't have the len attribute, we can loop through each element of the array. We can define a counter size or a counter. Then each time we loop through the elements of the array, we can increment the counter size. Finally, the counter will be the size of or the number of elements in a given array. Next, let's check whether a given array is an empty array or not. In C# or most programming languages, we can define an empty array by just giving two curly braces arr equal to an empty array. So this is an empty array. Or we can define an empty array by int arr2 equal to new uh, int of size 0. So these are the two empty arrays. In order to check whether an array is empty or has 0 elements, we can do that if array dot length equal to 0. We just print array is empty. Uh, Empty, else we will print not empty. So let's run my program. So it prints empty. If I give array2, it's empty. So let's add an element to array1 or array. They say it has 1 2. So this time it should give not empty. So the array is not empty. This way we can check if an array element is empty or not. So next we are going to see how we can clear or remove all elements from a given array and making it empty. Say I have this array with 2 elements. Although arrays have fixed size and length and they cannot be resized or dynamically shrink or increase the size. Therefore, we cannot directly remove all the elements from an array to make it empty. However, we can achieve the similar effect by creating a new empty array with the desired length. So here is an example. Suppose I want to remove all the elements of this array. So I just can simply say array equal to new uh, int of size 0. So this way I can clear all the elements of the array and make the size 0. Now let's talk about copying the elements of an array. Basically, there are many ways to copy elements of an array. But before that, let me show you something. If I wanted to create a new array equal to, I want to set this array to the old array. So in fact, I have not copied the old array or this ARR to new array. What I have done is I have assigned the reference of the same memory location to the new array. Now both new array and ARR, both of them are pointing to the same memory location. They are not copy of each other. So if this is my ARR, uh, this is going to have definitely a memory location, say 100 and 104, 108. So when I create new ARR and assign the reference to the ARR, basically this ARR is pointing to this memory location, and this new ARR is also pointing to the same memory location. They are not, in fact, two copies. They are the pointing to the same memory location or the same array. To prove that, let me print array, the old array, and also let's print the new array I have created, new array. So both of them should print the same item 1 2 3 4. But if I wanted to change the element of new array, say I want to say new array of 1 equal to 100. So we can see that these changes using the new array reference variable is going to affect the array also. When I print array here, a new array, both of them are affected since they both point to the same memory location. And new 100 and is printed, the changes are reflected to both of them. So to make a copy of an array, so manually we can do that, or we can use reference variables. We can use built-in functions in C#. So one way is to create a new array of the same size, 0 1 2 3, and simply loop through the elements of this old array and copy each item to the new array. So let's quickly do that and see whether they are two different arrays or they are the same. So I'm gonna again create a new array. Let's call it new array again. New array equal to a new int of for the size. I'm going to use the size of the old array.length. So next I'm going to loop through the elements of the old array for int I equal to 0, I less than array.length, then I plus plus. So I can simply copy a new array of I equal to array of I. So let's print both arrays, print old array, and let's print a new array. We can see both arrays have the same elements. Now if I wanted to change the elements of new array, so it shouldn't affect the old array since they are separate copies of this of the arrays. We have created new array and copied each elements. So if I say new array of 2 equal to 300, so it should only affect the new array, not the old array. This way we can see only the new array is affected. This way we can deeply copy the elements of an old array to a new array. So the second method is to use the built-in functions in C# to create a copy of array in C#. We can use array.copy method or the toArray method that comes from system.link. So first let's include the system.link or import the system.link namespace. System.link. So from this namespace, we are going to use the toArray method or also the copy method. So I have created a new array here, okay, of the same size. Then what I can do is I can use array dot array dot copy, and then I'm going to pass the source array from which I want to copy. Here in this case the source array is our old array. Then I want to copy pass the destination array to which we want to copy the elements. In this case it is new array. Then we want to pass the length, how many elements we want to copy. So I want to copy all the elements, so I want to pass array.length. So this way we can copy the elements of one array to another array, say whether it is deeply copied or no. So I'm again gonna change a new array of say 0 equal to 100. We can see that it is deeply copied and only new array is changed, so we cannot change the old array using the new array reference. So next method is using the toArray method. So let me clear all these lines of code. I have created a new array, so I can use the source array or the old array. It has a method of the toCopy toArray. Sorry, this is going to copy the elements of this array and assign it to this new array. So let's print that. We can see that old array, new arrays item is changed, set to 100, but the old array is not changed. So this way we can copy elements of one array to another array. Next, we have reversing the elements of an array. To reverse the elements of an array, say this is my array and have elements like 1, 2, 3, 4, 5. So what I'm gonna do is I will take two pointer, one pointer pointing to the beginning of array. Let's call this pointer start, and another pointer pointing to the end of array, and let's call this end. So using a while loop, I will start looping through each elements. So every time I loop, I just swap the item at the end start location with the end location. Then I will increment start to this location, and I will decrement end pointer to this location. So next, again, I will swap these two elements with each other. So for the first round of loop, 1 will come here and 5 will be copied here. For the second round of loop, 2 will be moved here. So since I will swap item at location end with item at location start, so 2 will go here and 4 will come here. Then end will be decrement here and start will increment. Both of them will point to the same location. I will check whether they are the same or whether start is less than the end pointer. If not, then I will get out of the loop. So my array is easily reversed. So to do that, let's write some code. Although there are some built-in methods to reverse an order, but we are going to write the code ourselves. So what I'm going to do is let's make it a little bit larger. So 5, 6, 7, 8. What I'm gonna do is first I will create two pointers and start pointer equal to 0, starting from the beginning of array, and end pointer equal to end of the array to get the end index. So I can use array dot length -1, because since index values start from 0, 0 goes all the way to length -1. So then using a while loop, I can loop through elements of the array from beginning and the end using these two pointers. So I check whether a start pointer, until the start pointer is less than the end pointer, I will continue looping and swapping the elements of the array. So here I will swap the elements. To swap that, we can define a temp variable, temp equal to array of start, then array of start equal to array of end, array of start equal to array of end, then array of end equal to temp, array of end equal to temp. This way we can swap the elements pointing the elements at the start location and the end location. Once we swap that, we are going to move the pointers towards toward the middle of the array. So to move the pointers, we can increment the start value start plus plus, and we are going to decrement the end pointer end minus minus. This way, once they meet each other and start is not less than the end, it will break out of the loop. So let's print our array here. We can see that our array is easily reversed. If you guys want to use the built-in methods, there we have array.reverse method. So we can simply reverse an array using array.reverse method. Let me comment out these lines of code. So I can do is arr array dot reverse. This is the built-in method. It takes an array, so we are going to pass our array here. So it's going to reverse the array. Next, let's talk about substitution operation, replacing all occurrence of a specific value in an array with another value. Suppose I want to loop through the elements of the array. Once I want to replace all fours with another value, so I can do that using a for loop, or for each loop. Let's do it for loop for int I equal to 0, I less than array.length. I check if array of I equal to 4, then I can simply set array of I equal to, say I want to replace all fours with hundreds. So this way I can do that. If I print here array, so all the element 4 will be replaced with 100. Or say I want to replace all the odd elements with 100, so I can do that if array of I modulus 2 not equal to 0. So this way we can check if an element is odd or no. If an element is not odd, we are going to replace all the if an element is odd, we can replace them with 100. If I say element equal to 0, it will check if an element is even, and it will replace all the even elements to 100. Next, we can find the unique element from an array, basically retrieving or counting the unique elements in an array. Suppose I have this array having multiple duplicate elements. I want to retrieve only the unique elements from this array. What I can do is say I have this array with multiple duplicate elements. What I can do is I can create a list data structure. uh, then I will start looping through the elements of this array, given array. Each time I loop, I copy each element to the list. Let's say I want to copy 5 here. Then this list has a method called contains, which checks whether an item is present in the list or no. If the item is present, it is going to return true, otherwise it will return false. Then I will try to add 5 here again. Before adding 5, I will check whether 5 is already in the list. If it is already in the list, I will not add it, and I will keep looping. Then I will add 4 here. I will add 3. I will add 2. I will add 1. Once I want to add 4, I check whether 4 is already in the list. Yes, 4 is already in the list. I don't add it. So at the end, I'm going to change this list back to array using the toArray method. This way we can get the distinct or unique element from an array of having duplicate elements. So let's go and write the code. First, I'm going to define a list data structure. To define a list data structure in C#, we can write list, but inside this bracket, we are going to define the type of values that we are going to store in the list data structure. In this case, we will store integer values. Then we are going to give a name to our list. So let's call it u list or unique list equal to new list of int. So this way we can define a list data structure. Next, I'm going to loop through the elements of the array for int I equal to 0, array.length I plus plus. Or we can use a for each loop. If before adding each element to the list, I can check if u list dot contains array of I. If this element is already in the list, what we can do, we are not going to add that, and we using the continue keyword, we can escape this round of loop and go to the next round of loop. Basically, continue keyword is used to escape the rest execution of the rest of the code in the loop and continue to the next round of loop. So if it doesn't contain the item, what we can do is ulist dot add array of I. So we just want to add array of I to the list. Next, at the end, we are going to convert the list to array using the toArray method. So I'm going to create a new array, int array, and new array, or let's call it uArray or unique array, equal to ulist or unique list. Since it's of type list, so we are going to convert it back to array using the toArray method. So now we have uArray or unique array. Let's print the uArray. uArray. We should be able to see only the unique elements. This way we can see the unique elements. The other way is using a set data structure. So let's define a set data structure or hash set in C#. It's called hash set. So the hash set, the type of hash set is going to be int. Let's call it set equal to new hash set of int. So using the hash set, we don't have to check for the elements, since hash set allows only unique elements inside the hash set. We can add only unique element in the hash set. We don't have to check whether it contains already. So we just can simply say set dot add of array of I. So for and I equal to 0, I less than, what is wrong? Okay, here. Next we are going to convert the set to array, and let's print that. This way we can get the unique elements of an array using a hash set or set data structure. There are also built-in methods in the system.length namespace to get the unique elements of an array. Let me delete these all lines of code. To get the unique elements of an array, we have the distinct function. So let me create a new array, new, and let's again call it uArray or unique array equal to old array, or this given array having the duplicate values has a distinct function. Inside the distinct function, this function returns INumerable. It returns INumerable, so we gotta convert it to array using the toArray method. So this way we can get the distinct elements from an array. Let me print the uArray. We should be able to see only the distinct values. This way also we can get the distinct values in C#. Next, we are going to check for equality of the two array, basically comparing two arrays to check if they have the same element in the same order. Here I have two arrays having the same element and the same order, so these two arrays are equal. As soon as I add a new element to the second array, they are not equal anymore since they don't have the same element. Also, if they have the same element but they are not in the same order, so those cannot be equal. To do that, first of all, we should check whether the two arrays or more arrays have the same length. Let's first define a Boolean variable or equal. Let's set it to true. First, we assume that two arrays having the same element. Then first we will check whether they have the same length or no. Array 1, if array 1 dot length equal to not equal to array 2 dot length. If they don't have the same length, so we are going to set the r equal to Boolean variable to false, means that they are not the same. Else, if they have the same length, then we are going to then check for the sequence of the elements of the array to be the same. So for that, we can use a for loop using any of the length of the array since they have the same length. So for int I equal to 0, I less than, I'm gonna use the length of array 2 dot length, since they both have the same length no matter whichever we want to use, I plus plus. Then inside the for loop we are going to check if array at index I of array 2 is equal to array of element, if then we are going to check whether the element at index I of array 1 is equal to the element at index I of array 2. So if array 1 of I not equal to array 2 of I, if they are not equal, we say we know that they are not in the same order. We just set or equals to false and we get out of the loop break. So but if all the elements are equal, we will never hit these lines of codes and our Boolean variable will be true. So at the end we check if r equal. If it is true, we will print equal, or the arrays are equal, else we will print not equal. Let's run our code. So the arrays are equal. Let me add another element here. Arrays are not equal. Say they have the same element but they are not on the same order. They have 1 2 3 4. Let's change, bring 5 here and 4 here, so they don't have the same order. They shouldn't be equal. Other way is to use the built-in methods that come in the system.link namespace. We have a sequence equal array, sequence equal method. So let me clear these lines of code. What I can do is I can create a boolean variable boolean or equal to array1 or array2, no matter, dot sequence equal. Then inside this I will pass the second array or array2. It will return if it will return true if they are equal. We can see this function returns a boolean. So if they are not equal, it will return false. So next we can check here if are equal, then we print equal, else we are going to print not equal. Let's run the code. They're not equal because the sequence is not the same. Let's change it to 4 5 again. We can see these are equal. So this way we can check for the equality of the given two or more arrays. So this was all about the operations we can perform on array data structures. Keep in mind that the availability of these operations may vary depending on the programming language or library being used, as well as any custom implementation you may have. So thank you guys for watching and see you in the next video. Please don't forget to subscribe to Code with Cougar. Thank you.